everyone, my name is Ashlesha and I will be starting this presentation on the T distribution. The T distribution is a fundamental concept in statistics, especially when dealing with small sample sizes. It was first developed by William Seeley Gosset, who published his work under the pseudonym Student. This distribution is bell-shaped and symmetric, similar to the normal distribution, but it particularly useful when the sample size is less than 30 and the population standard deviation is unknown. So moving on the next, we have importance of T distribution. The T distribution is crucial in small sample statistics because it adjusts for the increased variability that occurs when working with limited data. While the normal distribution works well for the larger data set, its assumptions often fail for smaller ones. The T-distribution accounts for this variability, making it an essential tool for two key purposes. The first one is constructing confidence intervals and second one is conducting t-test. So, confidence intervals allows us to estimate population means when the sample size is small and the population standard deviation is unknown. T-test, on the other hand, we use to test hypotheses about population means under similar conditions. This makes the T-distribution highly versatile and reliable for small sample analysis. Let's look at the characteristics of T distribution. Like, as you can see in the image, like the normal distribution, it is bell-shaped and symmetric but with heavier tails. This these heavier tails reflect the increased uncertainty when working with similar sample sizes when T-distribution more appropriate for situations where the normal distribution falls short. So moving on next, where we have the formula of T distribution. The T statics which form the basic of T distribution is a modified version of jet statics specifically for small sample size and where the population standard deviation is unknown. So the formula of T statics is, as you can see in the screen, T equals to sample mean minus population mean upon sample standard deviation um, upon root under sample size. In this equation, sample mean, this means sample mean, and here next we have population mean, and S means sample standard deviation, and N means the sample size. So the term S by Rotunda-Yan represents the standard error which accounts for the sample variability. This standard error is essential for determining whether the observed sample means differ significantly from the population mean. So let's move on the types of t-test. The first, the t-distribution is used in three types of t-test. First one is one sample t-test. Let's compare the mean of a single sample to a non-population means. Second, the two-sample t-test, also called the independent t-test, compares the means of two independent groups to determine if they are significantly different. Finally, the peer t-test compares the means of the same group at different times, example before and after treatment to assess changes over time. So for the rest of the presentation, I will like to call Nishan Shrestha from my group.
Thank you, Ashlesha. My name is Nishan, and I will take you through the rest of the presentation, starting with confidence interval using the T distribution. When constructing confidence intervals for small samples, the T distribution is preferred over the normal distribution. This is because with small samples, the normal distribution often underestimates variability, leading to inaccurate confidence intervals. The T distribution adjusts for this, providing a more accurate range within which the population mean is likely to fall. So, to calculate confidence confidence interval, we have the formula of x bar plus minus t alpha by 2 comma df multiplied by s by root under n, where x equals to sample mean, t alpha by 2 comma df is a critical value from the distribution for the desired confidence level, and s equals to sample standard deviation and n equals to sample size. So next, we have a sample example problem. So let's solve this using t distribution. So let's see what's given at the first. So here, suppose we have a sample student of 10 with average score 75. So our sample mean x bar equals to 75, and population mean mu is equals to 70. And so sample standard deviation for this problem is 5. And the number of is sample space n is given 10. So we have the formula t is equals to x minus mu by s by root under n. So first we have to calculate the standard error of the mean. So now SEM is equals to s by root under n. This equals to 5 by root under 10. This gives us 5 by 3.162, which is equals to 1.581. So next we have to calculate the t value. Now for the t value, we can write 75 minus 70 by 1.581. And this gives us approximately 5 by 1581, which is equals approximately close to 3.16. So what we found out that the in this problem we got the answer of 3.16. This was done to determine the statistically significance significance of the value that critical t value from the t distribution table for n minus 1 equals to 9 degree from the freedom d, which is df, at a given significance level. Example 0.05 for a 95% of confidence level. For a two-tailed test of alpha becomes 0.5 and 9 degree of the freedom. The critical t value for this solution becomes 2.26. Now let's talk about the assumption of t distribution. It's important to understand the t distribution operates under a few key assumptions. First, the sample must be drawn, and the observations should be independent of one another. Second, the population from which the sample is drawn should be normally distributed, which is particularly important when dealing with small sample sizes. Additionally, for two sample tests, the assumption of equal variance between the groups is required. Ensuring these assumptions are met is critical for the validity of t-test and confidence interval based on the t-distribution. So, moving on, we have the limitation of t-distribution. Despite its versatility, the t-distribution does have limitations. For instance, less For instance, it assumes that the underlying population is normally distributed, which may not be always the case. Especially with the small samples, it is also sensitive to outliers, which can significantly skew the results. Moreover, while it's designed for small samples, it becomes less effective and the sample size is extremely small, typically fewer than 5 observations. This assumption of equal variance for two sample t-tests can also be restrictive. And finally, the t-distribution is not suitable for non-parametric or categorical data. So now let's come to the conclusion of this presentation. So the t-distribution plays a critical role in small sample statistics, especially when the population standard deviation is unknown. Its ability to handle increased variability makes it more reliable than the normal distribution. For construction, confidence interval, and conducting hypothesis testing, understanding the concept of degree of freedom is also key, as it affects the shape of the t-distribution and accuracy of the result. Thank you for attending, and we hope this presentation has given you a clearer understanding of the t-distribution and its significance in statistical analysis from t-tester.